In this video, I'll be going over an example workflow using CurveSuite to generate a fluffy tail. The primary focus of this video will not be to showcase the end result, but rather go over the individual steps of the process and to explain each modifier's strength and purpose. Here I have a brand new Blender scene. So to start off, I will get rid of the timeline window. Go over to our asset browser window. I will select everything in the scene and get rid of them. In order to make the tail, we'll be using a cylinder object. So I will be adding a new cylinder to our scene. I will reduce the vertex count to start off to make it easier to work with. We can subdivide it later on. Underneath scatter suite, I will go to curve generation. And in edit mode, I will go to side view and rotate our cylinder and position it in such a way that you would expect a cylinder to be positioned. This is a decent enough starting point, so I'll be adding the modifiers. We'll be using cylinders to curves to drive the actual generation of the fur curves. We'll be using curves to fur curves to generate the actual cards that will serve as the fur curves, or rather the fur fluffiness of the tail. To start off, I will create a linked duplicate of our mesh using Alt-D. I will name one of them mesh and the other one fur, so it is easier to keep track of. I will hide the mesh one for now, and for the fur one, I will drag and drop the curves or cylinders to curves modifier, which will then turn it into a bunch of curves. Because curves are Blender's own proprietary data or object type, and they can't really be used in most programs as they are, we will be using the curve to mesh modifier to turn these into actual cards in the final step. So the end of our modifier stack will have to be curve to mesh, which I will drag and drop right now. But as you can see, it creates these weird triangles where the pointy end is on this side and then the white part is over here. To showcase why this is happening, I'll be adding a new curve object. I will add curve to mesh to this one as well. So here you can see this is just like a cylinder with 3 vertices. This is happening because the curve to mesh modifier actually uses the curve zone radius property to determine the size of the profile or the thickness of the profile. You can see that, and we're in edit mode on this one. We can actually adjust it. The curves generated by cylinders to curves actually have a root side, or rather a root side over here, and a tip side over here. And the root side has a radius parameter of 1, while the tips have a radius parameter of 0 that is fixed. There are ways to fix this using modifiers in CurveSuite, but for the time being I will skip over that part. And underneath curve generation, I will be adding curves to fur curves. Right, what this modifier does is it selects a target surface and an existing curve object, in this case curves generated by cylinders to curves, and uses these two datas to generate the fur curves that will be transforming to, or rather converting into, our fur cards. So As target geometry, I will be selecting our mesh object. And you can see it looks very weird right now because the fur curves generated by curves to fur curves, if I disable the curve to mesh, you can see these tiny strands and they're pointing in the opposite direction of where we want them to because they follow the overall direction of the curves that they're generated from. So because the root is over here, if we mute the curves to fur curves and then enable curves to mesh, because this part is the root and this part is the tip, they're actually pointing in that direction. And underneath our curves to our cylinders to curves modifier, we can actually flip the root faces, which will invert the generation so that these curves are oriented such that their root is the other end of the cylinder and the tip is the end that was previously the root. As you can see, the generation is still quite weird. If we enable our mesh object so that it is visible, I'll disable both of these modifiers for now. In wireframe mode, you can see that there are curves placed inside the cylinder, and the actual fur curves that were generated by this modifier are the ones where there are curves generated close enough to the surface. This is how the curves to fur curves modifier works. Here we have the curve proximity cutoff parameter, which determines how far away these, or rather, how close by should there be a curve for these fur curves to be generated from the surface. What this means is by increasing the proximity cutoff, you can actually make it so the proximity is not really a limiting factor anymore. Or alternatively, we can just set it to 0, which will disable that check altogether. But even with it set to 0, you can see the parts near the root are more full, whereas the parts near the tip have these very short fur curves. And then at the absolute tip, we don't have anything. This is because, as highlighted before, the curves generated by our cylinders to curves modifier actually have a radius of 1 at the root and then a radius of 0 at the tip. And if we enable this modifier again, underneath the geometry parameters, we have a parameter called radius effect on fur radius and radius effect on length. What this means is, while generating the fur curves from our existing curves, this modifier actually reads the radius parameter of our existing curve and then using it to generate different lengths or radii of fur curves. So if we set this radius effect on length to 0, the generated subcurves now have a uniform length. If we were to set the radius effect on fur radius to 1, the ones near the start would have their own full scale, and then near the tip they would get thinner and thinner. This is a good starting point, but I find these to be way too dense. And as you can see here, we have 94,000 triangles just for this alone, which isn't really usable for a full model. So what I will do is actually reduce the density by quite a bit. I will increase their radius and their length so that they cover more area. And here in the angle parameter, we can actually make them point further away from the surface. This looks better, but because we don't have a profile object selected under curve to mesh, it is just using a triangle shape as the profile. So what I'll do is I'll add in a path object. I'll call this profile. That's weird. I don't know why it's not rotating by 90 degrees. There we go. I will shape this so that it is more of a flat object, or rather a bumped surface. I'll reduce the resolution preview to 1. So here it has 3 faces again, but it is more pleasantly aligned. As our profile object, I'll select this profile. I will get in real close to make sure that it is aligned properly. And it seems it's not. Just to make absolutely certain that there isn't any alignment issues with the generated fur curves, use align curve to surface. This will have to be after our curves to fur curves, because otherwise, let me just show. I will set our wrapping parameters to 0 so that only affects the tilt. As you can see, if we place it before curves to fur curves, it actually affects the tilt of the curves we use to generate the fur curves, which looks very bizarre because the curves to fur curves modifier uses the existing curve's tilt, and the way the align curve to surface modifier works is it aligns the curve normals to the surfaces that you select for it. And the way normals work is quite complicated if you're not familiar with curves in Blender, but the gist of it is it will cause the tilt property to go in wildly different directions depending on where the curve is or how the surface it is being aligned to is oriented compared to the rest of the Blender world. In this case, you can see we have normals pointing immediately up and then to the side and then to the other side, so it is getting quite messy. Whereas if we place it after our curves to fur curves, it will make certain that the curves generated by it are getting aligned to the surface. So this is closer to the end result we wanted. But I'll go into our mesh object, which, since we are using linked duplicates, it doesn't really matter whether I go into edit mode for the mesh object or the fur object. As you can see, any edits I make here are reflected to the fur object as well. I will inset our root faces a tiny bit, and then I'll delete this face. We can even slide this part over a tiny bit. If you're concerned with the triangle count, you can further optimize it. It does sacrifice some of the voluminous look of the previous setup, but if we just get rid of these control points, we can have a singular line, which will then make these just regular triangles. In order to make it blend more, we can even use Blender's built-in data transfer modifier. After our curve to mesh modifier, select our mesh object. Under face corner data, we can select custom normals and nearest face interpolated so that the triangles blend them into each other. At this point, you can even call it done if you'd like, but in order to make more adjustments, we can go to edit mode for our mesh object And by enabling the retopology overlay underneath this mesh edit mode overlays, you can see what it looks like underneath all the cards, which makes it much easier to make adjustments. We can add in edge loops. We can slide existing edge loops. We can translate the existing vertices in any edit mode, however we see fit. We can even extrude the tip to make it longer, if you so desire. Should even be able to subdivide, but it might not be ideal because the generation doesn't really benefit from higher vertex density after a certain point, and instead it just makes it more complicated to work with. You can even use edit or the sculpt mode to push and pull the mesh underneath, but you won't get immediate real-time feedback. As long as you don't have dynamic topology on, it should be fine, but enabling dynamic topology will break it. You can see it's not longer in sync. You see beveling also works. As long as you don't mess with the overall topological structure of there being one face to be the tip, and or rather one flat area to be the tip, like we have right here, and then one area to be the roots. You can see it really doesn't have to be flat, it just has to be like a consistent series of faces, and then a singular connection between the two. Like if we, for example, extrude here, that might cause issues with degeneration, or if we delete a face. You can do pretty much anything you like. Now, if you want further customization, that is also a possibility. For example, I'll add in a path object or a path curve. And say you want the strands to be longer near the start and then get shorter near the tip. We can add in a transfer radius and tilt modifier, place it for our curve, or rather for our curves to fur curves, and then target it. Now, with our curves to fur curves modifier, we can enable radius effect on length. We can set it to be 1, and then increase our length parameter to be as high as you want the longest parts to be. And then in edit mode here, we can actually scale up or down the parts by scaling the control points of this curve. You can even have some degree of randomness to it by creating multiple curve objects within this singular or curve object. Let's call this proxy so it doesn't get confusing. And by adjusting the radius of these individual curves, what happens is, as this modifier reads the curves within this object, each individual curve here, let me disable all of them, each individual curve generated by our cylinders to curves modifier is reading a different but random curve from our proxy object and sampling its radius property, which in turn gets used by our curves to fur curves modifier to determine their length because we have our radius effect on length parameter set to 1. So the end result isn't truly uniform. It has a certain amount of natural variety to it. Alternatively, if you want a certain amount of natural variety, we can do it a different way as well. I will separate this single curve. I'll use it as a target of our transfer radius and tilt modifier. And here we have the random trim curves modifier. If I place it here, after our curves to fur curves, we can actually trim individual triangles or individual fur curves randomly using this modifier, which has a similar effect. But you can see when we do this, the tips are getting blunted off. They're not pointy anymore. The reason for this is when the curves are being generated by this curves to fur curves modifier, like how we had with just the cylinders to curves and our curve to mesh modifier, they have a radius of 1 near the root, or a smaller amount based on what you have your fur radius to be set, and then 0 near the tip. And as the trim curves modifier is taking effect, it's cutting them off at that specific point, determined by this tip min and tip max parameters. And if you don't want them to get rounded off like that, just moving it up doesn't do anything. So what we have to do is we will have to add in a new proxy. I will call this sub proxy. And we will have to edit a new transfer radius and tilt, so I'll just duplicate the existing one. I will select our sub proxy. I'll shrink it way down. I'll get rid of the in-between points since we're not going to be using them anyway. I will set the tip radius to be 0. I'll shrink the root radius way down. Though I think I did it backwards, possibly. You don't have to use Alt S to set the radius of these control points. You can also use the transform panel right here. Now with our new transfer radius and tilt modifier, when it is before random trim curves, because we're transferring the radius over from our proxy and then trimming it, we are still having the same result. But if we move it after our random trim curves, you can see now what the previous blunt edges were are now being the new tips, because we are transferring the radius after we're trimming what was previously the middle part of a curve. After we trim it is now the new tip, so the transfer treats that part as the new tip. Again, you could call this done if you so please, but we can also use our transfer radius and tilt to control the angle of these fur cards based on how far along the tail they are, so that we don't have such an aggressive bundling near the tip. I'm just going to get rid of the existing proxy curves. We'll set our radius effect on length back down to 0. I will rename our sub proxy to be radius proxy. I'll add in a new path. And I'll call this tilt proxy. I do not need to get rid of our transfer radius and tilt modifier, so I'll drag and drop it back in. And I'll place it immediately after our cylinders to curves modifier. I'll select our tilt proxy, and I'll select add tilt from target. So now we can use Ctrl T on this curve to adjust the tilt of our curves generated by cylinders to curves, which was previously not something we could edit. There's an alternative way to handle this as well, using this angle property or angle parameter and vertex screws, but that is very convoluted and annoying to work with, so I will not be showing it. And much prefer or much suggest that you use the angle parameter here and the tilt of another curve if you're pairing this modifier with the cylinders to curves modifier. We're not just limited to toying with the radius parameter of curves to adjust the scale of these cards. We can directly adjust them with the curve to mesh modifier as long as it's not affecting the length. So in this case, I can reduce the X scale to make them thinner. And if we go back here and increase the resolution again, we could adjust the Y scale to make this bump pop out more. In this particular shape, the Z scale doesn't really affect anything, but if we were to go to edit mode and push this part up, you can see the Z scale also affects the profile, as long as you have an actual three-dimensional shape to be used as the profile. For now I will set the Y scale down to 0. I'll actually go back to 1 resolution here. If you want a tail with more high definition fur cards rather than just these boring triangles, we can also do something for that. I'll reduce their density even further. I'll get rid of everything in between our curve to mesh, transfer radius and tilt, or curve to mesh and curves to fur curves, so that we're working with a blank slate. I will increase the length, reduce the angle. And here, if we enable our wireframe mode, you can see we still have triangles, but if we increase the curve resolution parameter, we can actually add in edge loops to these cards. So let's start with 24 for now. I'll increase the radius here as well for the time being. It seems like the curve to mesh modifier is at a negative scale, so I'll try to fix that as well. Just enabling flip places should fix it. If you're uncertain why the issue isn't happening, or why the issue is happening, it might be due to our scale properties or how the actual profile curve is set up. I will add a displace curves modifier. I'll place it after our curves to fur curves, and this current result is very messy, but we can change that. Here we have plenty of parameters to work with. The texture scale will adjust how much variation there is in the displacement caused by this modifier. So if you want a more uniform look, we can reduce these parameters. By default, this is just based on the XYZ coordinates. So if you want more variety along the Y direction, you can just increase the second parameter. If you want more variety along the X axis, you can increase the first parameter. And if you want more variety along the Z or the Z axis, you can increase the third parameter. If we enable sample root for noise, however, you can see now it looks like there's almost no displacement happening. This is because with this parameter enabled, each curve only reads its root position when sampling or generating the displacement texture. This just works as Blender's own built-in noise texture node, so if you're familiar with that node, this should be easy to understand. And we have the relative noise parameter, which when enabled, rather than using the XYZ coordinates to generate the noise, it uses the curve index and the spline factor, meaning that if you don't have the sample root for noise, the X parameter will be a number generated per curve, so that each curve has its own noise texture. And then the Y parameter will be a value going up along the curve's length. So reducing it creates a more subtle displacement that is less varied or less varied along the length of the fur curves, and increasing it also increases the variety along the length. And if we move along to the displacement parameters panel, we have a normal surface and three directions. Here we have tangent displacement, which is the most straightforward one, where it adjusts how much this modifier pushes up the generated fur curves along where their tip is pointing. It will make the generated curves longer if it is above 0, so I'll keep it at 0 for now. And then we have our normal displacement, which you might be thinking that functions weirdly or as not expected, because it is rotating the curves. If you go up, it's rotating them clockwise, because the normals of these curves are pointing to the sides. It's not the normal of the surface. Then we have our cross displacement, which is just a vector that is the cross product of our tangent and our normal. In this case, it just so happens to point away from the surface. And each of these parameters has this two-way displacement tick box, which if we enable for the normal, it just makes it so the displacement can happen not just along the positive normal direction, but also along the negative normal direction. And the same for the cross displacement. And if we select a surface for our normal surface parameter, this changes how these parameters work, where Whereas previously our normal displacement was using the normal of the curve, it now uses the normal of the surface that is close to the curve, but you can see it can cause some very jagged lines because the underlying mesh itself isn't very high poly, and our fur curves that, because of their length, may end up sampling very different parts of the mesh that's underneath the curves. Like the root might sample this point, and then the tip might sample this point, which have very different normals. But the sample root for noise parameters still functions, so you can enable that. But that still causes the displacement to be uniform along the length of the fur curves. That is where the fall off exponent parameter comes in. Normally, this modifier just applies a displacement of 0 at the root, and then whatever value is generated by these numbers and the noise texture at the tip. And this fall off exponent acts as a power for this blending, so by increasing it, we get these more rounded off displacement that just ramps up near the tip, whereas the lower values will have a very strong displacement effect near the root and now fall off or lose speed as they get closer to the tip. Because we are working with curves, we can actually use Blender's built-in curve modifiers as well. But you will need to be very careful with these because especially the guide ones will subdivide your curves. And since we have already have high resolution cards, if I, for example, add in the clump hair curves modifier and then place it before curve to mesh, you can see now we have a lot of faces. Our triangle count has shot up to nearly 400,000. One way to combat this is to just go to scatter curves curve manipulation panel and then get a resample curve modifier. And placing it immediately before our curve to mesh, we can make it so our curves are being sampled down in resolution after everything else has occurred, so that we can have a more conservative triangle count. I won't get too deep into the existing hair modifiers that are packed with Blender. These are much more technical and complicated than the ones in CurveSuite. Like for example, the clump hair curves has all these factor and shape and distance fall-off and distance threshold parameters that you can only really familiarize yourself with if you just mess around with them. But they are very powerful as long as you know how to use them, so I highly recommend you familiarize yourself with them as well. As a final note, I will go over how to shade these generated hair cards. You might be tempted to just use the material properties panel, but if we change the material slot here or add in a new material, you can see any changes made here do not actually reflect these generated cards. This is because you will actually need to use the modifiers panel where underneath our curve to mesh modifier, there's a slot called material. This is how you assign the material to these generated cards. Now if we disconnect the diffuse, it will actually work. And these generated cards actually have their own UV maps. You can see right here it has spline UV map name parameter. Just have spline UV map written. And the way this UV map works is if we add in a separate XYZ node, they're essentially just planes being deformed to these shapes. So the x-axis is just going from 0 to 1 on the profile, which if we get rid of our profile object, this also still works for the triangular shaped profiles. You can see it even has a seam split placed here, where it goes from 0 to 1 over 3 to 2 over 3 up to 1 on this face corner right here. And the y output is the same but along the length of the curve. So we have 0 at the root and 1 at the tip. So using that, we can actually use color ramps and such to procedurally color these curves. As far as using vertex colors to shade these go, you can actually do that as well. If you add in a color attribute, let's call it color. If we create another link duplicate of our mesh object, go to vertex paint, you can see any painting we do here is also reflected on the cards. But even though we have these gradations on the actual mesh object itself, the cards have more discrete coloring because at their core, if we disable all the other modifiers after our curves to fur curves, these curves are generated by distributing points along the surface of our mesh object and then extruding those points to become curves. So whatever value is at the point right here where the root is the point along the entire length of our curves. So keep that in mind if you're going to use color attribute, or alternatively, you can also use the UV map of our cylinder, but the actual UV map node will not work for this unless you apply the modifier. So we'll have to use our attribute node, which will have the same logic applied, where it will take over the UV map from the existing cylinder, but only where the root of our curves are. If you want there to be more smooth transfer of attributes, you can use Blender's own data transfer, but this might cause issues along the seams of the cylinder, so you may want to texture your tails accordingly so that the seams aren't in places where stretching isn't an issue for the textures. We already had custom normals transferred with data transfer, but if we shift click, we can also transfer UVs and colors. So now the vertex colors are transferred much more smoothly over to these generated curves. So for example, we could actually have our mesh object subdivided even further. Although if you're gonna subdivide, you may want to do it before you handle all the distribution, because it might change the end result. Now vertex painting is somewhat of a viable alternative to texture painting, albeit a bit leggy because of the data transfer modifier. I hope overall this video helps you familiarize yourself with the CurveSuite modifiers and how they work in conjunction with one another. If you have any further questions, feel free to ask me, but also to check the website if you are confused with how the parameters for each individual modifier works or what the purpose of a modifier is.